In this lesson, we are going to talk about graphing linear functions using a table. So I want you to think back to Unit 2. We've talked about input and output. And so this time for your input, we are going to choose our values for x, or sometimes we'll be told what values to use, but most of the time you will get to choose, and we're going to talk about the easiest ones to choose. And then your output is what happens when you plug that input value into the function. What do you get out of it? Okay, and so when we talk about a t-table, we're just talking about an input-output table. And so here's our process. We're going to pick some x values. We're going to evaluate the function and get some y values. Then we plot the points. Those points should make a straight line. This is a linear function after all. And then we're going to draw a line. And it's easiest to draw a line when you're using a ruler to make sure it's straight, especially if later on we're going to be using these lines to evaluate something. So I highly suggest using a ruler or your ID card or some sort of straight edge. I've even used just the edge of a notebook before. You want to make sure that the line extends through the graph. Remember, we're talking about a linear function, and so this does go from negative infinity to positive infinity in both your domain and range. So you want to make sure that it does extend through the entire graph, and that's why we use a ruler. So let's talk about this. On your Unit 2 test, you had a problem like this where you were asked to complete a table for the function. Okay, so over here we have this function, y equals 3x minus 2, and so they gave us the inputs. What do I do with those inputs? We're going to evaluate the function. I'm going to plug them in for x, right? So I'm going to say something like 3 times x minus 2, and what I'm plugging in is my input of 1, right? And I'm going to do that for every single input. So the next one, we'd have 3x minus 2, but this time I'm going to plug in 2, and then we simply evaluate that. So maybe that's plugging that into your calculator, or maybe you like to do that in your head or on some scratch paper off to the side. However you like to do it, you're going to end up with something like this. So again, we're plugging in those input values, and then we're evaluating, and this is the answer that we get. Okay? So now these make ordered pairs. The input-output of 1, 1 makes the ordered pair of 1, 1. The input-output of 2, 4 makes the ordered pair 2, 4, and so on. So then what we're going to do is we're going to go plot those ordered pairs, same ordered pairs. We're going to plot them on a graph. So 1, 1 would be about here. 2, 4 would be over 2 and up 1, 2, 3, 4. 3, 7, I'm going over 3 and then up 7. And then 4, 10, I'm going over 4 and up to 10. So you don't want any of these extra dots on here. The only dots that are part of this function are the big green ones that I have here. Okay? So then we want to take those points, I've now switched them to purple, and we want to sketch the line. So you're going to just start your ruler on one side, pull it through. There we go. It's pretty close. Okay, and don't forget we need arrows on each end. And there is our linear function. That's all we're doing. So we're just taking what we did in Unit 2 and adding one more step to that. Okay, so let's look at your rules here. Again, make sure you plot all of the points, as many as you can. Okay, then you're going to use a ruler to sketch your line or some sort of straight edge just to make sure that it goes all the way through the graph. Okay, that's rule number 3, make sure it goes all the way through the graph. And then this is super important, you have to put arrows on each end of the line to show that it keeps going. This is what makes it a linear function and not just a linear segment. So let's look here. Graph the line by completing the t-table, and here's our function. So the first thing we have to do is pick our inputs. I don't like to use a whole lot of negatives in my table, just because it just adds another layer that we could possibly make a mistake. So I like to choose 0, 1, 2, 3, Every now and then I'll switch it and I'll use a -1 in case I'm going to run off the graph. We should be okay with this one. Know that if you ever get a point that goes off your graph, you can either estimate it or you can go backwards and add in another negative to your input. Okay, so then we're just going to plug those in. So y equals 2 times 0 plus 1. Remember, I'm plugging it in for x. The next one would be y equals 2 times 1 plus 1. The next one would be y equals 2 times 2 plus 1. And finally, we'd have y equals 2 times 3 plus 1. And I'm sorry, I missed that these were all -2's. My fault. Okay. So then you can just take that and plug that into your calculator or do it in your head, however you want to do it. -2 times 0 is going to be 0, plus 1 would be 1. -2 times 1 is a -2. -2 plus 1 is going to be -1. -2 times 2 is -4, plus 1 would be a -3. And -2 times 3 is -6, plus 1 will be a -5. And you should be able to see some sort of pattern when we're talking about a linear function. If all of your inputs are in order, then you should see a pattern with your outputs. Okay, so I'm going to put those in my table. Those now create a set of ordered pairs, and when we sketch them, they will create that line because we're talking about a linear function. So let's go plot these points. First, we have the point 0, 1. So 0, 1 means I'm going to not move away from 0, and I'm just going to go up 1. Okay? And then we want the point 1, -1. So we're going to go over to the right, and then you go down 1, because that's where your negative is. The point 2, -3 means we go over 1, 2, and I'm going down 1, 2, 3. And then the point 3, -5. We go over 3 and down 1, 2, 3, 4, 5. Again, you don't actually want these added dots. I'm just trying to help you see where I'm counting. Okay, we've got our points. Now we can draw our line. So I'm going to draw a line to connect through those dots. Remember, you want it to go all the way through the graph. This is why we use a straight edge. There we go. And then what's the last thing we need? We need arrows on the end. And why do we put the arrows on the end? Because it goes on forever in both directions. Awesome. So now, what are we going to do when there's a fraction in front of the x? Do we panic? Do we quit? Do we just copy the answer? Or should we choose numbers that cancel out that denominator? Remember, we get to pick our input. Correct answer? We're going to choose numbers that cancel the denominator. We're going to use multiples of the denominator. What do I mean by the denominator? Looking at this fraction, -3/2, which one of those is the denominator? It's the 2. So we're going to choose multiples of 2, something that when I divide by 2, I will get an even number. So first of all, you can always use 0. Okay, always. And actually, I'm going to move that 0 because the next piece is you can always use the denominator. I'm going to use 2, and then I'm going to use the opposite of 2, which is -2. What's one more number that I could choose to be part of my table? 4. You could also use -4. You could use 6. All of those are multiples of 2. So if you were to divide those numbers by 2, you're going to get an even number. Okay, now if you don't pick those numbers, you're just going to get decimals. And if you know how to graph decimals, then that's great. You can use that. But it's just easier if we pick these numbers so that we get whole numbers as our answer or integers as our answer. Okay, so we're going to do the same thing. We're going to just plug into our table. Now notice, where did I put the negative that was out in front? Where did I put it? I'm putting it with the numerator. I just do that. You could also put it with the denominator. I always put it with the numerator just because that's my habit. And this is a negative. It just kind of blended in. And so then we're going to plug in all of our inputs. So I have a -2, I have 0, I have +2, and I have +4. And then you use a calculator to evaluate those. So this would become a +6/2, which is 3, plus 1 is 4. -3/2 times 0 is 0, plus 1 is 1. Then I have -3 times 2 is -6, divided by 2 is a -3, plus 1 is -2. -3 times 4 is -12, divided by 2 is -6. -6 plus 1 is -5. So then we can go and plot those points. So we have the point -2, +4. We have the point 0, 1. We have the point 2, -2. And we have the point 4, -5. Graph our line. Make sure it goes all the way through. And put our arrows on the end. Okay, why don't you figure out what are some possible inputs for this graph? Well, our denominator is 3. So that means I want to pick multiples of 3. So I'm going to pick -3, 0, and 3, and then I'm going to pick the next one up, which would be a 6. Great, so now evaluate those and plug them into your table. So what are your possible output values? Let's look at our input of -3. So 1/3 times -3 will make a -1. Evaluate, or -5 will give us -6. Then we have 1/3 times 0, which is 0. -5 would be -5. 1/3 times 3 would be 1. -5 would be a -4. And then 1/3 times 6 would be 2. -5 would be a -3. So let's put those on the table. -3, -6, we're going in the negative direction, -1, 2, 3, and then -6 down here. 0, -5 would be here. 3, -4 would be here. And 6, -3 would be here. Graph your line. And put your arrows on the end. And you have your linear function.